Hey, welcome to the Sunday Dojo show. This week we will have some fun with Sudoku puzzles. Sudoku, you know, for sure it's a game when you need to fill up the big square with numbers, so that in every row, column and this little subsquares, the set of numbers is unique, so every number appears exactly once. You can find a lot of information on Sudoku, its history and so on in Wikipedia. One of the information there is that average time for a person to solve the Sudoku is, let's say, about half an hour. We will try to solve a Sudoku that I have copy from online source with a program, and let's hope it will be a bit faster for us. We are aiming for 25 minutes. So I already started writing the first test case. We are using Python programming language this time, so the tests are written in a bit different way, but the basic idea is the same. The test case is called test row, and here we're testing that when we construct our Sudoku object, we are able to find what kind of numbers are already present in a row. As you remember, Sudoku needs to have this property that in every row, column and sub-square the numbers will be unique. So in solving those, finding what numbers are already filled in the row, column and the sub-square is, well, the basics. Here we set the make program to run the Python on our test scripts. So whenever I will type make now, this test will be run. And we can start with our Sudoku class implementation now. So we open new file, Sudoku Python. You can start writing the initialization. As you see, when we construct the Sudoku object, we pass a number of arrays or number of lists that way. Let's represent our rows. So let's call those rows. And once we have the rows data saved in the class, it's quite easy to implement the row function that should only return the row with a given number. That is quite short function. In the test case we actually need to return it as a set, and the test case is passing. That was easy. We can quickly put another test case, and we will do the same test only for columns. So in our small Sudoku games that we are solving now, we can put the first column, check the first column, and that should contain 140. And now to get a column is not that easy. We need to actually go through all the rows, and for each row we take the given number. So it's, we pass the x with all the rows, and for each row we return x element from the row then that will construct our column. Now the last thing to check, so we have the row, column, it's this subsquares. So again, if we have this minimalistic Sudoku with just one single place to put the number, that of course this subsquare is equal to 0. Here in this 4x4 we can have actually the subsquares 2 by 2. And now if we check the subsquare from position 1, 1, that should be the 0, 1 and 4 numbers there. And of course we need to provide the implementation. Now for this sub function, it takes both x and y. First of all, we need to find when our subsquare begins. That way you will store in the xs, like starts. And of course we also need to know the size of the subsquares. So let's add one extra variable to the class initialization. We'll call this subsquare sizes. So now this start of the subsquare will be the x divided by subset, and then multiplied back by the subsize. The same for the y. And now we can have an empty set to start with. Then we will go through the rows. So for row in self rows, but not through all the rows, only those from the subsquare. So those from the subsquares will be starting from the ys, should be, let's say, y start subsquare, until ys added self subsize. So those are the rows in this subsquare, and then in each row we will add all the elements. So we also need to provide a range here, row from xs until xs plus self subsize. So those will be the matching elements in the subsquare for every row that we visit. And then simply you can return this s. Let's check if the test case is working. We have the syntax error. We need to change this list to a set first. Now it's failing. We have the incorrect data. Let's see what is wrong. Yes, we forgot to actually provide this size of subsquares. So it was taking the default subsquares 1. Now we change it to 2, and everything is working just fine. Okay, having those basic operations, we can list all possible values that we could fill in into empty spot. You can notice that the empty spot we used value of 0 to mark. So whenever you see the 0 in the list, that's actually the place that should be still filled in. So in this minimum Sudoku 1 by 1, the only possible number to fill in is 1. And now in our 4 by 4 next example, we'll have at position 0, 0, there should be only 4. Actually no, 4 is not allowed either. So at position 0, 0 we cannot put any number. And then at position 3, 3 we actually could fill 1, 2 and 4. So now we need to provide this possible method of our class that takes also x and y as arguments. And now we will return the set, and we start with, let's say, all numbers that are allowed in the game. So those will be from 1 to size of our board plus 1. And then from the all possible numbers we need to remove those numbers that are already present in a row or a column, or this subsquare. We of course need to also include this size method. Here we can just return the length of the first row that we have. So we return the length of rows 0, and hopefully that will work. It seems to work fine. So now our program actually can help us solving the Sudoku, giving us the possible value at any location. But it's still not solving the puzzles by itself. To do so, we can look at one algorithm which is called depthfirst search. This is quite a generic algorithm, can be used for any, let's say, puzzles to be solved, and it's actually very, very simple thing. So let's write it here for, well, generic puzzle. So if we are given any puzzle, we first can check if it's already solved. If it's solved, we just return the puzzle as a solution. And if it's not solved, then we can check what are the possible moves that we can do from this puzzle. And for every move, we can actually make this move and check if we find the solution calling this recursive function again, calling this function recursively again. So we make a move from our puzzle, and this new puzzle we pass to this algorithm again. If it finds the solution, then we return the solution. If the solution wasn't found for any of the possible moves, then we think there is no solution from the puzzle that we were given. It's a very short function, and that function will help us to solve the Sudoku. So we can write a test for solving the Sudoku. So if we have this minimalistic one square Sudoku, it has only one solution. Namely, we need to put number 1 in the empty spot. Once we solve this Sudoku, the rows, the first row, should contain only the number 1. Put that in the test case. Of course, our class doesn't have the solve method yet. But now we can return and just call this depthfirst search. Now we use few more methods in the depthfirst search that our class is not providing. So first of all, we need to check, have a method to check whether the puzzle is already completed or not. So this is solve function. We will check if all the rows are filled with the numbers different than 0. So there are very nice function in Python that check if all elements in the list or any container is true. That's called all. There are a few other very useful functions like that. And to make sure that our is solved function actually give correct result, we can call it. So this 1 by 1 puzzle filled with number 1 is now solved. So that should return true. And the other Sudoku here has a lot of zeros still in it. So that one is not solved. It should go false. Have errors. We mistyped the method name. Is solved. Is solved. Now this is solved test case is oh, it's still failing. So the method doesn't work as good as we expected. This is because we missed the return statement. Okay, now it's test for solve is passing fine. The next method that we need to implement to use this depthfirst search is to list all possible moves. And this will be the most complex function that we will write today. The idea is that we will go through every possible or every empty location on the Sudoku board. So we go x in range and y in range, and if we don't have, or if no value, so if it's false at that location, so that will be the 0. Let's check what are the possible values in that empty spot, and we store them in a list together with this xy location. So we'll have a list of all the locations, possible locations of fill, and at each location we will have what numbers are possible. Just so this all possible initialized declared as an empty list. And if we didn't find any well, empty spot, then there's no possible moves at all. We can just return from the function. Now, if there are any possible some empty spots on our board, then we need to find the one with the shortest list of possible moves. So now we need to sort this all possible list and by well, the length of this third attribute. So we stored x, y, and the set of possible values. We need to sort the list so that it the shortest set of possible moves will come in front. So we use the lambda function here to let Python know how we want to sort the list. We just compare the length of the possible values, and then we can take the element 0 to have this location of the shortest. And we will know at which x, y we have the lowest number of possible numbers to fill in. And that will be our possible moves set that we will return to this depthfirst search. So here we use the Python generator syntax. We can instead of returning the list, we can actually call yield several times for every values that we would like to pass to the other function. Okay, small syntax errors, and now this function should be okay. Now Python is complaining that the Sudoku doesn't provide the move method that is using this depthfirst search. I think it's the last method that we need to implement. So we actually need to return a new object. And to have a new object, we copy the current object. So we make the deep copy, so we are sure that all data is replicated, that the new object will not have references to any data that current object has. And then we can just set the value at this given location, or xy, and we return the new object. So this move will take one argument, but for us this one argument is actually those set of three values, x, y, and the value that we should use. Now the tests are passing, and we actually managed now to solve the very first Sudoku. This Sudoku is so simple that I could, well, make it without the program, but it's well, quite a success that a program could solve it. Let's see if the program will manage the 2x2 Sudoku. So this is also quite easy for me to solve. If we have 2x2, the only possibilities are 2, 1, 1, 2. Yeah, the solution is correct. So let's test it now with this big 9x9 Sudoku that we have as our goal for today to solve. It says okay, it says that the solution is found in some milliseconds, but we don't see the solution. Just printed that it's a Sudoku instance. To see it in a nice way, we could implement the str function. So this underscore underscore str underscore underscore is a function that provide the representation, string representation of an object. So whenever we call print some object, that function is actually called. So let's just join all our rows printed and, well, concatenated with new lines. So we can see a very nicely printed solution for our Sudoku. Yes, now we are able to solve this in milliseconds. So it took us more or less same time as a good person to solve the Sudoku, but I think we have even more fun writing Python code than just finding the numbers.